Start.
Hello everyone, welcome back to this class where we are going to have the discussion on mixed question from the chemistry. So yes, what all things we have studied? We studied periodic table. In the last classes we had the theoretical session, right? Where we were discussing about periodic table. Apart from that, we have even taken the theoretical class of the chemical bonding. Now, since we have cleared all our concepts regarding that particular part which is important for the SSC examinations, now we'll do one thing. I am keeping all the previous year questions, but yes, all those questions we have already discussed. So let's see how you are going to give this answer in this super fast manner. And no doubt, I'll be again explaining all those concepts whichever are necessary according to the questions, and then we'll move forward. So in order to check your memory, in order to check whether your concepts are clear or not, what you will do? You will just try to check your answers and just tally whether you are correct or not. And yes, you are also going to have the revision because I'm going to explain the question along with the options wherever possible. Okay, so yes, let's move forward to the first question. The first question is, who proposed modern periodic table? Now we have four options here, that is Faraday, Mendeleev, Newton, Bohr. So this is the question which was asked in CHSL. But yes, it's not that it's only asked in CHSL, it is asked in other examinations as well. But I had to tell you that when it was asked, so that's why I mentioned in CHSL 2016 it was asked. Apart from this CHSL 2016, it is also asked in other examinations in other years also. So now, talking about the question, who proposed modern periodic table? If I talk about it, please remember, here there's a confusion. What is the confusion? One of the options which can come in the examination is Mosley. Now there would be confusion, sir, whether it would be Mosley, that is going to be the correct answer, or Mendeleev. So here I have to clear that doubt. When we are talking about Mendeleev, remember this part. When we are talking about Mendeleev, please remember, Mendeleev was the one who proposed this periodic table. Now when this periodic table was proposed by him, he told that the atomic, according to the atomic masses, we are arranging those elements. What I'm saying? Atomic masses. So I'm writing here. It was according to atomic mass. But what happened due to certain issues? There were certain things which were not looking correct. There were some of the elements which were not placed right. So what happened? This concept was actually discarded, but the mind which was before this particular modern periodic table was actually the mind of Mendeleev, which actually looked as if it is the present one. That is, in the present periodic table, that origination was in the mind of Mendeleev. Only the change that was done by Mosley was it actually changed the concept of atomic mass to atomic number. What's new about modern periodic table? In the modern periodic table, the elements which were arranged, they were arranged in the increasing order of their atomic numbers. I guess you got my point. So yes, if I talk about this modern periodic table, so modern periodic law, that is, elements are arranged in the order of their increasing atomic numbers. This was given by Mosley. So never be in the confusion. Please remember, the modern periodic table which we see actually originated in the mind of Mendeleev, where he was talking about atomic masses, but there were certain issues which were later on discarded, and those issues which were discarded, they were actually resolved, and the new concept which came after the resolution, that was your atomic number. And yes, in the present times, the modern periodic table that we are using is the one which is given by Mosley. Got my point? So whenever it is asked who proposed modern periodic table, so you will say, sir, he was none other than Mendeleev. But that was according to the atomic mass. The present one is according to the atomic number, which is given by Mosley. Simple. So yes, answer B is the correct answer. Next. So here is the periodic table. Now the next question which may come in the examination is, if I'm talking about this periodic table, how many elements are there? So please remember, modern periodic table is containing 118 elements. Got my point? Now apart from this, this is the basic one, but still it is asked. So let me tell you, it has total 1, 2, 3 and so on up to 18 groups. So how many groups are there? We have 18 groups here. Now if I talk about periods, how many periods are there? So the number of periods which are actually present here are 7. So number of periods are 7 and total number of groups are 18. Okay. Now one more thing. If I talk about this periodic table, which one is actually a noble gases? So here group 18 is actually your noble gases. Or we can talk about inert gases. If I talk about 17, very important question. Please remember, they are known as halogens. What are they? They are halogens. Simple. Okay. Let's move forward now. Next question is, the modern periodic table consists of 18 groups, 7 periods. We have just discussed about it, right? We have just discussed. Now, we are asking what is the atomic number of element placed in the second group and fourth period. Now, for understanding this part, let me tell you, we must know how to create that periodic table. What's that? I have told you, please remember the starting 20 atomic numbers. That is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and so on. So here, I'll write for you hydrogen. Here we have helium, then lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Simple. Now we had a trick. What? Halina ki rab se faryad. Remember? Halina ki rab se faryad. Beta मांगे कार स्कूटर बाग राजी देन बैगन आलू गाजर इन थैला देन कहें शिवजी सुने पार्वती देन नहीं प्रियांशी एस सुरभि ओस से टी पो फसल भर e. You can create any trick of your own, fine, but it's just a trick. Helium, neon, argon, krypton, xenon. So if I talk about this periodic table, we know that if I go from left to right, we have total 18 groups where we have missed the between part. But yes, if I'll talk about it, first period, second period, third period, fourth period, fifth period, sixth period, seventh period. Groups, first, second. Now here we were asked, what was the question? Question was, second group, fourth period. Let's go. Second group, I'll take blue color here. Second group and fourth period. So this is the one. What's that? Calcium. So if I talk about calcium, calcium is going to be the correct answer over there. And what was asked? It was asked which is that particular element. Sorry, it was asked atomic number of the element. So now we have understood about the calcium, right? And one more thing I have already told you. If I'll go with the sequence order, I know that it is according to the increment in their mass number, atomic numbers. And now if I know that atomic number of hydrogen is 1, helium is 2, lithium is 3 and so on. So, and I have already told you, till 30 please try to remember, but minimum till 20. Now, I'm talking about 20 and we must be aware of 20 is the atomic number of what? Calcium, right? So, you can even directly tell. I have just given you the trick how you have to create the periodic table. So, if you can create the periodic table, you can clear up all the concepts, all the questions can be done. Electronegativity, electropositivity, number of valence electrons, valency, everything can be sorted out using this periodic table itself. So, we'll be having more questions and then we'll be having a look at it. Let's move forward now. So yes, here what we are talking about calcium. So for the calcium, we know that its atomic number is what? 20, right? So here, just have a look. So here we have calcium where? In the fourth group, in the fourth period and second group, right? So what's the atomic number here? For the calcium, we have atomic number 20. So option number A is going to be the correct answer. As simple as that. Okay. So I guess this point is clear to you. Next, moving forward to the next question. Next is, Rn is the chemical symbol of which element? Now, we have discussed all these parts, right? So if I talk about Rn, what is it? Now, if I talk about these options, so without going towards the option, let me tell you it is what? If I talk about radioactive elements, so one of the option is going to be with that. So yes, now I guess you will be able to relate it, right? And please do not go with radium here. I'm going with the gas part, fine? So yes, what is the correct answer? Here, Rn is actually standing for radon. So option number B is going to be the correct answer. Simple. Now, so now there's a special announcement for you all. This is the awesome thing which is going to be very, very beneficial for you. If you're going to buy any of the examples of course, whichever it is, use code Diwali75 because we have Diwali Dhamaka offer where Exampur will give you 75% discount just by using code Diwali75. Now, where are these courses present? Obviously, at our application. Now, if I talk about our application, please have a look at this part. Application is including all those things which we want as a student. Whether it is current affair, whether it's free PDF, whatever it is, we will be getting each and everything at the platform. Just go to the Play Store, type Exampur over there. Then Exampur will be installed. Now what you have to do, just click on the open buttons, do some registration and start using it. Okay. So we have next question. What is the chemical symbol of iron? Now from here, if I talk about iron, we are already aware of, sir, what? Iron. That means we are talking about Fe. But the important thing is, iron is very much required in our body. Now this is with the bio part. Iron is very much required in our body, right? And from where we can get it? We can talk about spinach. We can talk about other green vegetables as well. But spinach would be the perfect example. Now if I'm getting iron in my body, obviously I'll stay healthy and stay strong. But the main thing is that when I'm talking about this iron, that means I must know about its ore. We have already studied metallurgy, metals, non-metals, right? Last week we have studied. So if I talk about those metals, non-metals part, so here, if I am talking about iron, from where will I get this iron? From where is this iron extracted? From where is this iron extracted? Can you tell me? So yes, if I talk about the ores, please remember that's hematite. What's it? It's hematite. Now the important thing is, from this hematite ore, we are actually taking this iron. But the main thing is, from this word hematite, just go with this word heme. Heme. Don't you think it is there in our blood as well? What's that? Hemoglobin. Totally correct. If I talk about this word, it is relating with hemoglobin. Now this hemoglobin word is actually derived from this heme word, hematite, and globulin is a protein which is present in our blood. In the blood circulatory system, we have discussed it. Again, we will discuss it when we will be starting with the bio part, actually with the mixed session now. So here, globulin is the protein. So hemoglobin which is present in our blood, it actually gives the red color to the blood. Very important part. Please do not forget. The red color of the blood is actually given from this hemoglobin part itself. Fine. Now, if someone asks you about the fluorine, so what's so special about fluorine? So if I'll go with the reactivity series, where you're comparing other elements with this fluorine, please remember fluorine is going to be the highly reactive one. Fluorine is actually very reactive. Okay, then let's move forward. Here iron was the correct answer. So here if I talk about iron, what's the atomic number of iron? So the atomic number of iron is 26, and we can see that here we have elements. Where is the iron? Iron is actually present here. That is in the 8th group. Okay. So now we can move forward and we have the next question. In a periodic table, while moving from left to right in a period, the number of dash remains same. So just try to think about its answer. Till then I'll have water. Can you give this answer please? Yes. So I was talking about a question where I'm saying when I'm moving from left to right. Now the best part to understand this is when I'm standing here, not in this manner. When I'm in this manner. So this is my left and this is my right. So when I move from left to right, so while moving from left to right, I must know the number of shells will remain same. I'm writing here, the number of shell remains same. But when I move from top to bottom, here the number of shells, are going to increase. Very, very important. Do not forget what I'm saying. When you will move from top to bottom, the number of shells are going to increase. But when you are moving from left to right, the number of shells will remain same. Simple. Okay. So what we are talking about here, the question is in a periodic table, while moving from left to right in a period, the number of dash remains same. So we are talking about left to right. Correct. So here what is happening? The number of shells are going to be same. True? Okay then. So here option number C is the correct answer. Next please. Which of the following atom has the lowest ionization potential? Now, the question is, which of the following elements has lowest ionization potential? Now, what's ionization potential? If I talk about ionization potential, what's that? It is the amount of energy that is actually required to remove the electron from the outermost shell. We have studied, right? So here, if I'm talking about the lowest ionization potential, what do you think? What is going to happen? We have just discussed in the previous question. What was that? If I'm going from top to bottom, the number of shells are actually increasing. So now if the number of shells will increase, what will happen? Here is the positive charge, here is the negative charge of electron. So if the distance will increase, then obviously easily this electron can be taken out. But if I talk about this part, positive and negative part, so these are nearby. So opposite charges attracts each other. We know that, correct? If we are talking about the nearness, so here it is nearby. So here it would be requiring high amount of energy to come out. But here it can be easily taken out. So let's have a look at these options. If I'll go with the nitrogen. So let's make a periodic table here. Short periodic table. So it was hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. This is the sequence order. Here we have discussed Nahi, Priyanshi, L, Sabhi. Then this is completed. Nitrogen is there, oxygen is there. Now Halina ki rab se faryad. Now let's try to compare this part. We have understood when we are talking about nitrogen, oxygen, arsenic and this cesium. Just try to compare them. If I go from top to bottom, here the number of shells are going to be maximum in comparison to nitrogen, oxygen and arsenic, right? So easily electron can be taken out from this part. What if I go to this part? Here they are already non-metals, bro. What are they? Non-metals. They are actually sitting in order to take the electrons. So how can you actually take out electron from them? You are just doing opposite. What? They are actually requiring electrons to attain the stability. And the question is asked, lowest ionization potential. How it is even possible? Right? So easily electrons can be taken out from this part because it is, first of all, it is in the first group. That too in the lowermost part, number of shells are maximum. Easily electron can be taken out. So what is the correct answer? The correct answer is going to be option number B. That is cesium. Simple. So this is the point. Let's move forward to the next question. Next we have ionization potential for the inert gases. Just discussed. Don't go with the CHSL examination. It's not only for CHSL, CGL. We have other examinations where we can talk about even JE. Many examinations are there. In those examinations, when these questions are asked now, they are actually twisted. The only thing is that the way question is actually twisted. So if you want to make it difficult, we'll create options in such a manner or we'll just twist the question in such a manner that it will look as if it is hard. We are unable to get that point. But if our logic is clear, we can clear all the things. Okay, let's try to understand this. Ionization potential, we have understood the amount of energy which was actually required to take out the electrons, right? So now if I talk about ionization potential for the inert gas, what do you think? What would be the value here? Inert gas, talking about 18th group, that is, I'm talking about 18th group over here, that is noble gases. And noble gas already has their outermost shell filled, that is, they have already the configuration in such a manner that their outermost shell is already filled. Their duet octet are already complete. So they are neither going to give you the electron nor they are going to take the electron. They are not going to be part of all those activities. This means if you want to take out this electron from the outermost shell, you will be requiring very high amount of energy. What? Very high amount of energy. So please remember, here ionization potential is going to be very, very high. Got my point? Next. So here, this is the 18th group where we will be requiring very high amount of energy in order to take out the electrons. But if I go with this part, here easily electron can be taken out. You have understood this, right? Next. Now talking about the correct order of electronegativity of FNOP. Let's see. Can you answer this? What is the correct order of electronegativity? What is electronegativity? If I talk about electronegativity, here they are actually requiring the electrons. So now the tendency of needing the electron, tendency of gaining the electron, where it will become maximum? Obviously towards the non-metals. That is, if I'll try to go from left to right, electronegativity will increase. Very important. But if I'll go with electropositivity, it is totally different. Fine. Electronegativity and electropositivity are actually opposite of each other. Fine. Inversely proportional. So if someone will ask you, if you're going from left to right, what is the trend of electropositivity? It will actually decrease, but electronegativity will increase. So let's have a look. When I try to make the periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Then we have FOPN. F. I'll take red color. F is here, O is here, P and N are left, right? N is also here. FON is there, then P is left. So, nahi Priyanshi or Surbi. So, P will come here. Right? So, yes, let's try to compare it now. When I take red color and try to compare them, I know that if I'm going left to right, electronegativity is increasing. If I'll go from top to bottom, electronegativity will decrease. So here, let us check. So here, first of all, if I'll go here, first of all, from left to right, fluorine will be maximum, then oxygen, then nitrogen, and then phosphorus. So FONP. Maximum at FONP. What is the correct answer here? The correct answer is going to be option number C. Simple. So just try to understand the trend, and please remember the starting 20, minimum 20, but if possible till 30 atomic numbers, so that easily you can draw the periodic table and you can easily take the answers. Simple. Okay. So here we have option number C as the correct answer. Next is, what is the unit of radioactivity? Now the topic of nuclear chemistry has started. So yes, if I'm talking about the radioactivity, we must remember who was the one who has discovered it. So he was none other than Henry Becquerel. So Henry Becquerel was the one who has discovered radioactivity. Now, when Henry Becquerel discovered this radioactivity, what is it? There are some of the elements, because of their instability, what they do, they keep on disintegrating, and from themselves they keep on emitting this alpha, gamma, delta rays, and because of that, what is happening? Here some of energy is being lost. Now, what are its example? If I talk about some of the elements, here you can talk about uranium, plutonium, many of the radioactive elements are there. But the important thing is how you are going to actually measure this radioactivity. So there's a device. We have some question for that. I'll be asking you. But right now, try to understand. Its unit is what? Its unit is according to the discoverer's name. That is, please remember, I'm talking about SI unit. This we have studied in the physics. Its SI unit is actually becquerel. It is what? Its SI unit is actually becquerel. Do not forget. And the most important thing is, it's not only the unit, it's only the SI unit. If I talk about other units also, then other unit includes Curie also. But Curie is not the SI unit. It is actually misconception. Some of us think that Curie is the SI unit. No, Curie is not the SI unit. SI unit is becquerel. But yes, Curie is the unit, but not SI unit. Simple. Okay. So here, what is the correct answer? What is the unit of physical quantity? So here, becquerel is the correct answer. Now, if I talk about this radian steradian, what is that? Obviously, this is not from the chemistry part, but we must understand. These are actually what? These are the unit of angles. You remember solid angles we were talking about. And what about this Kelvin? Kelvin is the unit of temperature. It is the unit of temperature. Now, we know that there are 7 fundamental units, right? So yes, here if I talk about temperature, so Kelvin is not only the unit but also the SI unit. It's also important. As I was talking about this becquerel, becquerel is the SI unit of radioactivity, but we have Curie also as the unit. In the similar manner, Kelvin is actually the SI unit of temperature. But yes, Apart from this Kelvin, we have degree centigrade, we have degree Fahrenheit, and one more. Since you are from the CGL part, you must know Reamer is the scale. So here, Reamer, Kelvin, Celsius, Fahrenheit, all these are the units of measuring temperature. Okay. Now, moving forward here. In India, nuclear weapon was tested at which location? So was it Sriharikota? Was it Bangalore? Was it Pokhran? Or was it Kanchipuram? So if I talk about this nuclear weapons testing, this was done in 90s, right? So here, I'll tell you about it. Here, actually, at that time, we had Prime Minister Atal Bihari Vajpayee ji. We know about a famous scientist, Dr. APJ Abdul Kalam, right? So, okay, but I'm not going in the depth. Right now, we must understand this. This nuclear weapons testing was actually done at Pokhran. Okay, so here option number C is going to be the correct answer. Next question. Device which is used for detection and measuring of all the types of radiation. So I was just talking about radiation. I've just told you. We were discussing about radioactivity, right? So yes, if I talk about the device which is used for the detection and measurement of all the types of radiation. So what's that? Is it Geiger meter? Sorry, is it Geiger counter? Is it polarimeter? Is it calorimeter or radiometer? So yes, you are absolutely correct. The correct answer is going to be A. That is Geiger counter. Next. So I was talking about Diwali Dhamaka offer. This is the offer for you all where you can use any of the course by, if you want a discount on that particular course, what you'll do? You'll use Diwali 75. Now this Diwali 75 is the code which is going to give you the 75% discount. But this offer is valid till 27 October. Next question. Which one of the following is not a radioactive element? Now this one is important. Why? Because here everyone is having the ending part with EM. So it seems as if all of them are radioactive, but it's not. So yes, let's see who will give the correct answer. Which one of the following is not a radioactive element? So yes, obviously uranium is the radioactive element. We have already taken its example. Apart from that, thorium, plutonium are also radioactive elements. But if I talk about zirconium, it's not the radioactive element, and hence option D is correct. Others, if I talk about, they are actually not stable. They are not stable. Because of that, what is happening? They keep on disintegrating, and yes, they keep on giving those alpha, beta, gamma radiations. Okay, so here option number D is the correct answer. Next, radioactive noble gas is dash. Now we discussed about this. You must be wondering, so when? In the starting itself, when you are starting this radioactivity right now, what I gave you, there was a question which I told you that this was previously asked. And yes, I was talking about the twisting of the question. So in this way, question is twisted. Now the question is asked, radioactive noble gas is which one? So is it xenon, helium, neon or radon? So yes, radon. We have discussed about it, right? So radon is the correct answer. But one more thing is there. From these particular options, one more question is asked. What? See, this was actually asked radioactive noble gas. What if I ask you about the stranger gas? I'm writing here. It is asked in the examination. Stranger gas. Please remember, this is what? This is actually your xenon. Right? Now there's another question, because many questions are asked in the examination. What if I ask you about helium? So we know that helium is used where? If I talk about balloons or other places where we can talk about hot air balloons and all, why it is actually preferred over hydrogen? There's a reason behind it. Because hydrogen is what? It is actually combustible. That is, it will burn. So in order to prevent that dangerous part, we are actually using this helium. Right? Now comes the neon. What's so special about this neon? If I go with neon, please remember, this neon is actually used as a beacon light. If I talk about those hotels light and all, this neon is used, and please remember, it is even able to penetrate the fog. So yes, these all were the specialities of all the four options, and all these questions are actually asked. But for this question, no radioactive noble gas, your option number D, that is radon, is going to be the correct answer. So yes, option number D is the correct answer. Next, please. There is no change in radioactive element that is, there is no change in the mass or charge during dash emission. So if I talk about these emissions, alpha, beta, gamma emissions, so actually there's either change in the atomic number or there's the change in the mass number, something happens. But if I talk about this gamma emission part, what happens in the gamma emission? There is no such change. That's why option number A is the correct answer. Next, radioactive samples are stored in lead boxes. Lead is actually used because of what? Why actually lead is used? We could have used other things. Why we are only using lead? So there must be some reason behind it. So what is that reason? There must be some reason, right? So if I talk about these radioactive samples, we are aware of they are doing what? If I talk about any of the radioactive samples, they will be emitting those radiations, right? So if those radiations are actually there, so there must be someone who can actually absorb it. So who is the one who can actually absorb it? So yes, for the absorption, we'll say that we are using lead. So lead is actually what? Lead is actually a good absorber. Lead is what? Lead is actually a good absorber. Very important. Fine. So yes, option number C is going to be the correct answer. Next, the nuclear forces are dash. So are they charge independent? Are they spin independent? Are they charge symmetric or long ranged? So here, nuclear forces. So if I talk about nuclear forces, here please remember whether I am talking about whatever it is. Here, nuclear forces are actually not dependent on the charge. They'll be same there. And one more thing, when we are discussing about several forces, I'll give you the example. We are talking about fundamental force in the physics. Remember that part? When we were discussing fundamental forces, we were talking about which forces? We can talk about gravitational force. Remember? Gravitational force. Then, apart from gravitational force, we had electrostatic force. What? Electrostatic force. Then, we were even talking about this nuclear force. So, if I'll go with these forces, which was the weakest force? So, weakest force was actually a gravitational force. But the strongest force was nuclear force. But one more thing, this is also asked in the examination. When we are talking about the strongest force, please remember the strongest force which is there. It is actually your short ranged. The strongest force is actually your short range force. What my point? So please do not forget. So yes, here we have given long range. No, this is wrong. Wrong. Spin into no. So here charge independence is going to be the correct answer. Okay. Next. So now we were talking about Diwali Dhamaka offer, right? So when we are talking about Diwali Dhamaka offer, we must know we are actually going to use that code Diwali 75, but it is only valid till 27th of October. Now, when you will be buying that course, where you are going to get those courses, they are obviously present at our exam for official application. Now, not only those courses, apart from that, we are having live paid courses which we are already talking about in that Diwali offer, along with the test series. Then we have free subject wise and topic wise quiz with the report card. Not only this, we are having job alerts, admit card, examination date. Then all exam previous year PDF with the solution. Apart from that, free all India scholarship test with the report card. Then topic wise free live classes, free full length and sectional test with the report card, free exam wise PDF and practice set PDF, daily, weekly and monthly current affair. And then we have unlimited subject wise practice questions. All these things at a single platform. What we have to do? We will go to Play Store. There we will be typing example. After that, we will be clicking on the install button. Then open part, we will do registration and start using it. Next. So radioactive element emits what? We have understood this. There is no need to explain, sir. When we talk about radioactive elements, so one of the elements you have already told that we can talk about uranium, we can talk about plutonium, we can talk about thorium. They actually keep on emitting alpha, beta, gamma radiations. Right? So yes, this is the correct answer. That is option number D. Next. The element which is commonly used in nuclear reactor for producing electricity in the nuclear fission. Discussed about it. What's that? Yes, that's the uranium. So uranium is the one which we are actually using in nuclear reactors for producing electricity. Now, please remember, whenever you are talking about those nuclear reactors, what? Nuclear reactors. So the process which actually occurs here is what? The process which is occurring here is nuclear fission. But if I'm talking about this nuclear fission reaction, here we will have neutrons bombardment. Now, if it is of very high energy, what we are going to do? We are going to use the moderators. So if someone asks you what particular moderators are used, so we must remember all those things. What all things are there in this nuclear reactors? There we have cadmium rods, right? Then we have heavy water. Heavy water. It is actually asked in the examination. Let me write for you. Its formula is again and again asked repeatedly. So that is D2O, heavy water, which is actually used in nuclear reactors. So these all things are important. We'll be having some of the questions regarding that. Let's have a look. So nuclear power reactor acts on the principle of what? Just discussed. What? If I talk about nuclear power reactors, it works on the principle of nuclear fission. But since fusion is also given, so I have to tell you. Please remember this fusion actually takes place on the sun. It is asked in the examination. Not only sun, you can talk about even hydrogen bomb. So hydrogen bomb or sun, here nuclear fusion is taking place. But yes, the question was from nuclear power reactor. So it is actually acting on the principle of nuclear fission. In Hindi, we call it Navikya Vikhandan. If I talk about fusion, in English, we say fusion. In Hindi, we say that it is Navikya Sanlayan. Okay. Next we have who invented the nuclear reactor. There must be someone who have actually invented this. So I gave you the trick. If I talk about its invention, I told you there would be a large amount of energy, and that energy can be in the form of heat. So we'll feel what? Heat. In Hindi we call it garmi. From that garmi we can relate Fermi. From nuclear reactor, heat, that is garmi, Fermi. So Fermi was the one who has invented this nuclear reactor. Although it has no relation, this trick has no relation with the real concept. But yes, it's just a trick in order to remember. Whenever we'll be finding question in the examination, we'll just try to click. Okay, garmi, Fermi. Acha, nuclear reactor. So yes, Fermi was the one who has invented this nuclear reactor. So option number A is going to be the correct answer. Next. The two elements which I use to absorb the neutrons in nuclear fission during the chain reaction. I told you, during the chain reaction, we need something. So here, during the chain reaction, if I talk about the absorption of the neutrons, what we are going to do? We will be using some rods. Now, what is that? Obviously, we are not going to use this plutonium, uranium, right? Uranium is again given here. So what is the option which is left is your boron and cadmium. So boron and cadmium is actually used. Or we'll say boron or cadmium rods. Okay. So we have next question now. Graphite is used as a dash in nuclear reactors. So we'll talk about graphite. So what is it? Is it used as a fuel? Is it used as a lubricant, moderator, electric insulator? Just discuss about it, right? So yes, graphite is actually used here as a moderator. Next. Heavy water is used as a coolant in the nuclear reactor. Now heavy water is what? We have discussed about it. What? When I was talking about heavy water, we knew its formula is D2O. Why I gave you this formula? From this formula, you can actually try to relate these options. So what is that? Water rich in minerals. Will it be correct? Maybe. Let's see. Ozonized water? No man. If I talk about ozonized water, that means I'm talking about ozone and all. No. Eradicated. Water containing minerals of heavy metals? Doesn't seem correct, right? Water containing heavy isotopes of hydrogen atom. Yeah, that's true. If I talk about isotopes of hydrogen, we have protium, deuterium, and tritium, right? So we have DO here, D2O. So obviously, first option is also going to be wrong. So here, option number D is correct. That is water containing heavy isotopes of hydrogen atom. So here, option number D is going to be the correct answer. Next. Now we have other part where we will be talking about this chemical bonding and all. So for understanding this chemical bonding, we need to understand about ions. So I'll go with the ions. We have cations and anions over there. So yes, let's understand with this question. Formation of cation occurs by dash. Either by gaining electron, loss of electron, gain of proton, loss of proton. What is the correct answer? Yes, sir. We have discussed about it. When I'll talk about metals part, where I can talk about lithium or sodium. So I'm talking about sodium. Sodium does what? It donates one of the electron, and when it donates the electron, it becomes positively charged. And this positively charged part means this is actually what? Cation. Yes, what is the question? Formation of cation occurs by what? We have discussed donation of electrons. So yes, after the donation of electron, that means loss of electron. So option number B is going to be the correct answer. Next. So here, if I talk about the donation of electrons, so these are the ones who can actually donate the electron. These are the ones who are actually taking the electrons. But one more thing, very important one. If I talk about this hydrogen, this is actually non-metal. Hydrogen is actually the non-metal which is present in the first group. Very important part. Do not forget what I'm saying. Hydrogen is actually the non-metal which is present here. Now you must be wondering, sir, in the first group and the non-metal, let's try to understand this fact. If I talk about hydrogen, its atomic number is 1. This means it has only 1 electron. Now if it has 1 electron, just think of it. We know that metals actually donate the electron. Now if this electron will be lost, it will become H+, that is there would be no electron. So obviously, it is only having 1 electron. Everyone wants stability. It also wants to complete its duet. So if it will donate electron, how this will happen? So that's why this is not in the category of metal. This is actually in the category of non-metal, where it requires 1 electron. It cannot donate electron. So that's why it is non-metal. Okay. Moving forward. A bond formed by the transfer of electron between the atoms of the elements is called what? So when we talk about the transfer of electrons, discussed, right? So whenever we are talking about transfer of electrons, that is always ionic bonding. If I talk about covalent bond, this means we are talking about sharing. Here, sharing of electrons is there. If I talk about coordinate bond, here what is happening? For the coordinate bond, we need a condition that there must be a lone pair of electrons. This is very important. If lone pair of electron is there, only then it will happen. So all these concepts are clear. Now that means we can go in the super fast manner. So yes, ionic bond is the correct answer. Next, if I talk about the question, the compound which contains ionic bond, obviously NaCl, Na positive, Cl minus, force of attraction, and it becomes NaCl. That is, it donates the electron and it gets the electron. So yes, transferring of electron, that means ionic bonding. Next, why do atoms form bond? Obviously, why? To attain the stability. We also want stability. These also want the stability. But one more thing is that to decrease the potential. What? To decrease the potential energy and to attain the stability. So option number A is going to be the correct answer. Next, electrons in the highest energy level of the atom are called what? So we're talking the highest energy of the atom. So yes, nucleus and these electrons. So the electrons which are there in the outermost shell, here which are known as valence electrons. Here valence electron, that is option number C is going to be the correct answer. Simple. So yes, electrons in the highest energy level of the atom are called valence electrons. Next, bond formed by the sharing of electrons between the atom of the element. Just discuss. What's that? That's covalent bond. For the ionic bond, we have transferring. For coordinate bond, we require lone pair. Next, the compound which has covalent bond, obviously N2. So yes, N2 is going to be the correct answer. Next we have which of the following contains both ionic and covalent bond. So when I talk about both ionic and covalent bond, just have a look at this NaOH. Na positive, OH minus. So this means gaining and donation of electron, that means ionic bonding. And if I'll go with OH, sharing, that means it is covalent as well. So NaOH is going to be the correct answer. Next we have mark the compound which possesses ionic, covalent and coordinate bond. All of them. So yes, what can be the answer here? Here we can go with NH4Cl, right? So here, what is the correct answer here? So here, the option number C is going to be the correct, that is NH4Cl. Now, this is actually including ionic bonding, covalent bond and also the coordinate bond. Next, strongest bond is which one? So please remember, if I'm talking about this particular option, remember, the more the number of bonds, more it is stronger. So here, this option number B is going to be the correct one. And if I talk about this ionic, covalent, coordinate, here covalent bond is the strongest bond. Which one? Covalent bond. Okay, so here B option is correct. Next, how many lone pair of electrons are present in N2? If I talk about N2, see, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now we'll share them. So it is going to be 1, 2, 3, 4, 5, 6, 7. No. So we'll do one thing. We'll try to make it. It would be 1, 2, 1, 2, 3, then 1, 2, 3, and here. So it is 1, 2, 3. Now let's try to count it. For this nitrogen, how many electrons are there? 1, 2, 3, 4, 5, 6, 7, 8. In the similar manner, for this nitrogen, how many? 1, 2, 3, 4, 5, 6, 7, 8. Now, if someone will ask me how many electrons are present in this N2, so lone pair, one pair here and one pair here. That is, two pairs are there. But if someone asks me only about one nitrogen, so I'll say in the one nitrogen we have only one lone pair. But if someone is asking me about N2, so I'll say two. So please remember the correct answer would be N2. For N2 it would be 2, but only for N it would be 1. So for N2 we will be having 2 here, right? Why? Because again I'm taking this example where these are the electrons which are actually lone pairs. Lone pair, it is also lone pair. And yes, these three were actually involved in this bonding part. Remember, this was what? Triple covalent bonding. So yes, option number 2 is going to be the correct answer over here. Next. So we have already discussed this part, that is the ionization potential of the inert gas is always high. Next. So we have discussed this part, right? So all these questions were very important. And yes, I'll talk about the sequence order again. The correct order of this electronegativity of FNOP is, that is FONP is the correct answer. That is option number C will be the correct answer. So all these were the questions which we have discussed from periodic table, from bonding part, and from nuclear chemistry. These are the important ones. And yes, in the next class, we are going to discuss about the questions from the chemistry in everyday life. There are some of the topics which we have more to discuss, and after completion of this chemistry part, we'll be starting with the most mixed session of physics, chemistry, and bio. Fine. So okay then. Bye bye everyone. Please take care and enjoy. Whatever doubt is there, let me know in the comment section. We'll be discussing about it. Okay. So bye bye. Please take care. Enjoy.